Hello again, folks. Hope you're all safe and well and making some progress with the remote learning that's been set. And as I've said before, hopefully these videos are of some help to you. This one is to accompany Year 9 Combined Factbook Week 4. So that's the week commencing the 29th of June. Lesson 1. Year 9 Triple, it is the week 3, so the week commencing the 22nd, lesson 2, and Year 10 Core, it is your week 3, so the week commencing the 22nd, lesson 1. I think that's your only one that week, and we're looking at covalent bonding. So, they're the key facts that we need to cover, where covalent bonding happens, how it happens, and a couple of points about how it can be represented diagrammatically. So that's what we're going to look at in this video. So we looked at ionic bonding, the fact that it was the bond that occurs between metals and non-metals. Covalent bonding is bonding that takes place between two non-metal or between non-metal atoms. They can be atoms of the same type, or they can be different types, but it must be two non-metals. If it's two non-metals, it is covalent bonding. Now, when we looked at ionic bonding, if you remember, we spoke about the fact that it is to do with atoms losing and gaining electrons, and therefore becoming charged and forming either positive and negative ions. Covalent bonding, the same idea in terms of the atoms are trying to obtain a full outer shell, but it happens slightly differently. Okay, they still want to achieve a full outer shell, but rather than losing or gaining electrons, what they do is they share electrons. Now, the way that we will have been spoken to you about in terms of remembering that is there's a little saying that sharing is caring, and covalent begins with a C. So sharing, caring, covalent. Okay, so rather than losing or gaining electrons, the atoms will share their free electrons in order to give both of them a full outer shell of electrons. So, when that happens, any pairs of electrons that are being shared are referred to as bonding pairs, and they create a covalent bond between them. And you can have one single sharing pair, bonding pair, or you can have more than one bonding pair, as we'll see. So, if we look at chlorine first of all, chlorine is a non-metal. It forms covalent bonds between its own atoms. So it forms covalent bonds between two chlorine atoms. Now, just a word on the formula. It's fairly straightforward, but wherever you have numbers in a formula, that tells you how many atoms of that substance there are in a molecule of that formula. So a very simple example, it would be chlorine, Cl2. That means there are two chlorine atoms in a molecule of that substance. Another simple covalent example would be H2O, water, or H2O. The 2 comes after the H, so that tells you there are two atoms of hydrogen. There's no number after the O, so that tells you there is one atom of oxygen, H2O. Okay, that's what the numbers tell you in a formula. There will be others I'll refer to as we go through. So if we look at chlorine, this is just showing you the outer shell electrons. Chlorine has 7 electrons in its outer shell. So if we have two chlorine atoms, each one has 7 electrons in its outer shell. That means there is a space in each of these outer shells to be filled. Now, chlorine will not lose electrons to each other. That might achieve a full outer shell for one of them, but it does nothing for the other one. And chlorine is electronegative, so it will not do that. So what happens is, rather than losing or giving up electrons, what they do is they share electrons in order to achieve 8 electrons in their outer shell. So this one now, because they are sharing these two electrons, this one now has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. And this one now has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. Because they are sharing that electron pair in the middle. Now, because there is one pair there, it is called the bonding pair, and it forms a single bond, okay, which can be represented as a single line. We'll look more at diagrams later. So a single bond is abbreviated with a single dash. So that shows you the chlorine molecule, Cl2, two atoms of chlorine joined together. Now, oxygen would be another example. Oxygen is another example of what we call a diatomic molecule. Diatomic means two atoms, and again its formula is O2, which tells you that in a molecule of oxygen there are two atoms of oxygen. So, oxygen has six electrons in its outer shell. Again, this is only showing you the outer shell. So 1, 2, 3, 4, 5, 6. And then in this one, 1, 2, 3, 4, 5, 6 again. When it bonds, each of those two unpaired electrons is shared. So, what happens is, they share those two pairs, and again, that gives this oxygen atom now 8 electrons in its outer shell. 1, 2, 3, 4, 5, 6, 7, 8, because of the two shared pairs, and it gives this one 8 electrons in its outer shell. 1, 2, 3, 4, 5, 6, 7, 8, because of the two shared pairs. So what that means is, in the middle, we now have two pairs being shared, we have two bonding pairs. And that gives us what we call a double bond. Now, the same way that in the chlorine atom, the single bond could be shown by one dash, the double bond can be shown by two dashes. And that shows us the oxygen molecule O2. Now, in terms of representing covalent molecules, we can do that in various ways. There is what we call the 2D ball and stick model, which literally just shows you the atoms and the bonds between them. Single bonds shown as one line, double bonds would be shown as two lines. Okay? Or we can have the 3D ball and stick model, which attempts to show us the configuration of the atoms rather than just how many of each there is. We can also have dot and cross diagrams, which show us where the electrons are being shared. Okay? So the cross would represent an electron from one of the substances or one of the atoms. The dots would represent the electrons from the others. So in this case, carbon, the carbon electrons are dots, 1, 2, 3, 4 of them in the outer shell. The hydrogen electrons are crosses, each one has one of those to share. And that shows us the 4 pairs of electrons that are shared between the 4 free electrons that carbon has and the free electron that each of the hydrogens has. Now coming back to the formula, CH4, well again, there's no number next to the C, so that tells us there's one of those. There's a 4 next to the H, that tells us there's 4 of those. So in that molecule, there is 1 carbon and 4 hydrogens. Carbon and hydrogens are non-metals, so that tells us it is a covalent molecule containing 1 carbon and 4 hydrogens. Okay, so those are some of the ways we can represent the molecules in a covalent substance. Ball and stick model, 2D, 3D ball and stick model, and again, as we spoke about with the ionic bonding, you can also have a dot and cross diagram. Now, in terms of the pluses and minuses of each model, the 2D model is useful, but it has some limitations. It does show us which atoms are in the molecule and how many of each there are, and how many are bonded to each other. It doesn't give us any idea of the shape of a molecule, and it shows 90-degree angles. So where you have bonds like the carbon and the 4 hydrogens, it has them at right angles. Whereas actually, in a molecule, to be more accurate, the angle between covalent bonds is more like 109.5 degrees. You will not be asked that angle, but you do need to know some of the limitations of these models. So the limitations of a 2D ball and stick model is that it doesn't show you the true shape of the molecule, and the angles are always 90 degrees between bonds. In a 3D model, it does try and show you the actual angles, and it does try and give you some idea of the shape of the molecules. Okay, in terms of a dot and cross diagram, it gives you an idea of where each electron has come from. So in this one you can see there are 4 dots. So those must be the carbon electrons because it has 4 in its outer shell. There are also 4 crosses, but they will have come from the hydrogen atoms. Okay, the reality of it is that the electrons aren't dots and crosses. Okay, obviously all electrons are the same, but they are represented differently to show that they are being shared. 2 different representations of the electrons in order to show that the electrons have come from both atoms in each case. So they are being shared between the 2 atoms. On paper, obviously, the electrons don't move, but in reality, scientists currently believe they are constantly moving in covalent bonding. So constantly changing position, but at any one point, they are between the 2 atoms between the nuclei of the 2 atoms bonding. Okay, so dot and cross diagrams are useful. They do show us where each electrons have come from. They do represent the fact that the electrons are being shared between the atoms, but they have those limitations as well. Okay, so just back to the fact book, what was being covered is covalent bonding is between non-metals. So whenever you have a bond between 2 non-metal atoms, even if they are the same type of atom, that will be a covalent bond. It involves the sharing of electrons. Remember, sharing is caring, covalent begins with a C. The sharing of electrons results in each atom having a full outer shell, which gives them stability, which is what they are trying to achieve, and that's why the bond created is a strong bond. Covalent bonds can be shown with dot and cross diagrams, as we've looked at. They can be shown as just simple lines between atoms, or they can be shown using 3D model. And as I've said, each one has its advantages and disadvantages, which we spoke about just briefly there. Last thing, the molecular formula shows you how many atoms of each element there are in that molecule. So that's the information it gives you. Okay, so those are the key facts you need to be aware of for covalent bonding. Hopefully this video has helped with that. Thank you.